Hey guys, and welcome back. We hope you're having a good summer and are glad the exams are over. I know I am. Now these next few videos we'll be doing are all about experimental technique. The experiments we'll be using are straight from my primary school books.
Hey guys, so the original experiment was how does the height of the ramp affect the distance traveled by the car? And what was done was there was different positions of different heights, but that was using different number of books. So position 1 was 10 books, 18 books, and then it went down to 6 books, 4 books, and 2 books. And then investigating the distance traveled by the car on the flat surface. But what we'll be doing to improve this is actually measuring using the tape measure the height of the ramp in meters and also the distance traveled in meters. So you can see that the graph was the different number of books and then the distance traveled in centimeters. And as you can expect, as the number of books decreases, the distance traveled also decreases. Hey guys, so I'm going to be going through the equipment that you will need. So obviously we'll be using books again, but this time obviously we'll be measuring the height because these books are of different thicknesses. So it maybe if we had same thickness of book, we could just measure it using the number of books, but we'll be measuring the height. Then obviously you need your measuring tape and then this other measuring tape, which is better for measuring the height. And then your sticky tape, which is actually used mostly just as references. So this reference will be where I'm going to be releasing and not pushing. That's the other key thing. We won't be pushing, we'll be just releasing. And then obviously the ramp. And then this other piece of tape is another reference point to measure. So let's say the car reaches here. I'll be measuring the distance from this point to the back wheel of that car just to keep it consistent. And then as this keeps on going up, again, the procedure will be the same. This will have to line up over here and then, I don't know, it could end up here. And then again from here to the back wheel of the car.
So to start this experiment, you measure the height from the table to the tape where the car will be leaving from. You don't measure it to the top of the ramp because that's not where the car is leaving from. Now, I didn't factor in, this has both inches and centimetres, so I need to adjust it to read the centimetres because inches aren't real because that system sucks. That is 3.2 centimetres. Now, as you can see, I'm measuring it from eye level to the point on the ramp, which is not visible for some reason. Now, this is to reduce any chance of parallax error. Parallax error is caused by when you're reading measurements and you read from the wrong angle. It's more prominent in something like titration or reading from a measuring cylinder, but you can achieve parallax error from anything. So that was 3 point... I've honestly forgotten by now, but I'll rewatch this video to check my results. It's a great thing of having a partner filming you. Now you line up the car, so the middle of the back wheels at the back of the tape should be perpendicular to the direction of travel. And release, don't push, release. It has travelled a certain distance, which is quite a big distance. Now, you are supposed to measure from the back of the ramp, end of the ramp, not the back of the ramp, to the back of the car. The reason I've unrolled it this far is because that side is 150 and this side is 1. It's been a while since we've done an experiment. Now, we measured initially from the middle of the wheel. So we will be measuring again to the middle of the wheel. And that is 15.4 centimetres. And you will record these results and then repeat at least 3 times, maybe more if there's any outliers, any obvious anomalies. And then you will change the height and repeat the procedure.
So now what I'm going to be doing is comparing the two different tables for the two different experiments. So if we start with Courtney's table from when he was 6 years old, obviously it isn't as sophisticated as the one that we did today. So as you can see, the distance traveled is correctly written in centimeters at the top. However, there should be a slash there instead of brackets. This is because technically you're dividing by that specific unit. And because of that, that means that you don't need centimeters in each row afterwards. So it should just be 150, 140, 120, 70, 40, and 0 without the centimeters written afterwards. Also, I'm assuming that the ruler that he used when he was 6 probably had some millimeters on it. So I think he's probably rounded off these numbers to 150, to 140, to 120, to 70, to 40. So he could have done it with 1 decimal place, possibly, as we did today. So all of our readings are to 1 decimal place, and we wanted to keep it consistent. We have also done 3 repeats and averaged the repeats to reduce the effect of any random errors in the experiment. So now what I'll be doing is comparing the two different graphs that we had. So in Courtney's 6-year-old graph, I'm not too sure what type of graph this is. If it's a bar graph, I'm not too sure what it is. But the point remains that as the number of books increases, the distance traveled in centimeters does also increase, which is fair enough because he supported the statement. And he's answered the question of how the height of the ramp affects the distance traveled by the car. So now, if you go to our first graph with 6 points, it's obviously, again, we've supported the same argument because as the height increases, the distance traveled also increases. However, this was meant to be in direct proportion, and as you can see from the graph, there is a y-intercept, which means that it's not in direct proportion, which means we didn't fully support the hypotheses that we set out. Then our second graph looks slightly better because it's more linear, but then again, it has that systematic error because of the fact that it has a y-intercept. And that systematic error may be to do with the 0 error in the tape measure, in both of the tape measures that we used.
So one of the sources of error was that the ramp itself was not always perpendicular to the point on the table where the car would be leaving the ramp. So the car would not always travel straight, as you may have seen in the time lapse. Another source of error was the ramp itself wasn't always completely level across the ramp. So depending on where you put the car on the ramp, even just a slight adjustment would change the results, potentially drastically, although it didn't appear that way. Another source of error was that when the car left the ramp, as you may have seen again, it didn't travel straight at points. It would swerve, it would change direction slightly after it already left the ramp. And the last set of readings we attempted to collect, you may have seen the car caused the ramp to tilt because the apparatus was not set up appropriately. So the weight of the car acted as a moment against the weight of the ramp, causing tilting, which meant we couldn't collect those results, or at least at the point where we could collect the results, they were incorrect because of that.
The graph wasn't exactly linear, but in an ideal world, it should have been linear. The reason for this is because the gravitational potential energy that the car had when it was at the top of the ramp would be converted to kinetic energy when it reached the bottom of the ramp. And then that kinetic energy would be converted into work done against friction when it is moving horizontally across the glass floor. So that should mean that the distance traveled should be proportional to the height of the ramp, because overall the gravitational potential energy is being converted into work done against friction. The equation for gravitational potential energy is just mgh. M and g are obviously constant in this experiment. And then the equation for work done against friction is just force, the frictional force, which is mu r, which r and mu are also constant in this experiment, times by the distance. So in an ideal world, the height should have been proportional to the distance traveled.
Thank you guys for watching this video. In our next video, we're going to be doing another one of my primary school experiments. using paper parachutes. We hope you enjoyed and remember to stay sciencey.